Greetings and welcome. In this section we have question 10 from DBE 2022. This is based on probability. The question reads as follows. Flags from 4 African countries and 3 European countries were displayed in a row during the 2021 Olympics. Determine the total number of possible ways in which all 7 flags from these countries could be displayed. So we know that this question is coming from the fundamental principles of counting. I always put it like this. So we have got 7 countries here. So we're going to put 7 blocks. Okay. 1, 2, 3, 4. These are African countries. And then we've got 1, 2, 3. These are European countries. So A for African, E for European. So now, in this case, we are required to find the total number of possible ways in which all the 7 flags will be displayed. So we know this is 7 factorial. So it's 7 factorial because we've got 7 separate countries. So in how many different ways can we rearrange them? Okay, which is there are 7 ways by 6 by 5, 4 here, 3, 2, 1. Okay, that's what 7 factorial means. And then we are going to enter that one in the calculator, which is there are 5,040 different ways. You don't have to write this expansion here. All you just have to write is there are 7 factorial different ways, which is 5,040 ways of arranging the flags. And then 10.12, determine the probability that the flags from the African countries were displayed next to each other. So we know that probability, we have to find the how many different ways can we rearrange these flags so that the African countries are together. Okay, so in this case, when the African countries are together, we would rather group them as one. So let's take those 4 countries as one item because they are together. Okay, so when we take this one, this is 1, but the other 3 countries are separate. So we have 2, 3, 4. So we've got 4 items here that can be arranged in different ways. So that will give us 4 factorial ways. So there are 4 factorial ways in which these countries are grouped together. However, when we come to the African flags themselves, there are 4 of them. So we can also rearrange them in 4 different ways. So there are 4 factorial multiplied by 4 factorial ways. So that is the different number, the total number of possible ways in which we can display these such that the flags are together. So when we punch that one in, 4 factorial by 4 factorial, so this is 4 factorial multiplied by 4 factorial. That one, okay, 4 factorial multiplied by 4 factorial, that will give us 576. So there are 576 different ways where the flags will be next to each other, the African flags will be next to each other. Therefore, our probability now, the probability that the countries will be together, so there are 576 different ways out of the 5040. Okay, we simplify that again. So we've got a 576 over 5040. So we get 4 over 35. 4 over 35. So that is our probability there. And then 10.2, we are given that A and B are two independent events. So highlight that one, independent events. And then we have PA, the probability of A is 0.4, the probability of A or B is 0.88. So calculate the probability of B. So here we have got a clue that we are given PA or B, which means we have to use the addition rule. The addition rule says that PA or B is equal to probability of A plus the probability of B minus the probability of A and B. Okay, but we know that we are given that A and B are two independent events, so we have to, if they are independent events, it means that PA and B is equal to PA multiplied by PB. So we can substitute into this addition rule for probability. So PA or B we are given is 0.88. So that is 0.88 is equal to the probability of A we are given is 0.4 plus the probability of B is what we are calculating here. So that will be PB, that's our known, minus the probability of A and B. Now the probability of A and B, because they are independent events, we can express that as the probability of A multiplied by the probability of B. So let's calculate this, the probability of A multiplied by the probability of B, of which the probability of A we know already, that is 0.4. So let's simplify that further. 0.88 will be equal to 0.4 plus PB, probability of B, minus probability of A, that is 0.4, by probability of B, that is 0.4 PB. Then collect like terms and solve for PB. So in this case, we'll get the 0.4 comes over here. We've got 0.48 will be equal to PB minus 0.4B, that is 0.6 PB. Okay, and the solving for PB, so our probability of B will be equal to 0.48 divided by 0.6. Enter that one, 0.48 divided by 0.6, we'll get the probability 4 over 5. So the probability is 4 over 5, or you can write it as 0.8 in decimal form. Then the next question, 10.3, we are given that there are 120 passengers on board an aeroplane. Passengers have a choice between a meat sandwich or a cheese sandwich, but more passengers will choose a meat sandwich. There are only 120 sandwiches available to choose from, so the probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18 over 85. Calculate the probability that the first passenger will choose a cheese sandwich. Okay, so the best way, this is an example of compound events where we get one event after the other. For example, we see that there is a first passenger who picks up a first passenger chooses a sandwich, and then another one. So there are two events, one after the other. Those are compound events. So the best way of dealing with that is to prepare a tree diagram. So we can prepare our tree diagram here as let's look at the two events that are happening here. First, we have got the first passenger. Okay, we consider the first passenger who is going to pick, and then we also consider the second passenger. So, but now we have got the two options here. Okay, the first passenger can choose a meat sandwich or can choose a cheese sandwich. So let's call that one MS for meat sandwich, and then this one is a cheese sandwich as CS. Okay, so the first passenger can choose MS or CS. Then the second passenger can also choose MS or CS, okay, a cheese sandwich. Similarly, we can also put it here. The first passenger can choose cheese sandwich, then an MS, or like that, okay, CS. So let's extract now the information from what we are given here. There are 120 passengers on board, and passengers have a choice between choosing this we are given here. Now we have to work with unknown. There are only 120 sandwiches available. So we can say that, okay, out of 120, we are going to write the probabilities here. Let's say there are X people who choose the meat sandwich. Okay, there are X people who choose the meat sandwich. So we know that for every 2 branches or 3 branches, the probability these 2 fractions must always equal 1. They are equal to 1. So if there are X passengers who choose meat sandwich, so the remainder, which is 120 minus X over 120, will be choosing cheese. For example, let's say if 100 people, because we are given a clue here that there are more passengers who will choose meat sandwich. So the clue is that the number here who are going to choose MS is greater than the number who choose CS. So I'm just using, for example, let's say 100. So 100, if 100 choose MS, so here we are going to have 120 minus 100, which will give us the remaining 20. Okay, so I hope you follow that. And then now we are also given that the probability that the first passenger chooses a meat sandwich and the second passenger chooses a cheese sandwich is 18 over 85. So now here we are given the probability that we choose MS and CS. So we are given the outcome over here, which is 18 over 85, the outcome of PMS times PCS. Now the probability here, after choosing the meat sandwich, the probability that the next person who will choose CS, there will be how many cheese sandwiches left? Since the first one was a meat sandwich, so we still have 120 minus X sandwiches, meat sandwiches, out of 119, because the first one now has been picked. Okay, so the first meat sandwich was picked, so we now have 119 and we still have 120 over X. Okay, so that is what we have here. I guess you can go on and fill in the rest, but all the other branches, they are not necessary to fill in here. So now we are required to calculate the probability that the first passenger will choose. So this is the probability that we are required to calculate over here. So now let us start from this, what we are given here. So probability of MS, okay, and CS, the probability that we choose meat sandwich and cheese sandwich is equal to P ms, those are independent events, multiplied by PCS. Okay, so which is, as we are given here, we are given that this is 18 over 85, the probability of ms and that one. So it's 18 over 85 will be equal to probability of ms, which is x over 120, multiplied by the probability of CS after choosing the first meat sandwich, that will be 120 minus x over 119. So the aim here is to calculate the value of x. So in other words, how many meat sandwiches were picked, and then that will help us also to find the number of cheese sandwiches that were chosen. Probably that we choose the first passenger chooses the meat sandwich. So we have to solve this one. Let's simplify this part, the right side. So this is x multiplying that. So we are going to have 120x minus x squared over multiplying the denominators as well. Okay, let's go to our calculator. 120 multiplied by 119, that will give us 14,280. That is 14,280. This should be equal to 18 over 85. We can cross multiply then. Let's bring it over here. So when we cross multiply, we got 18 multiplied by 280. Okay, now I have here, so let us multiply by 14, that one, multiplied by 18. I get 225, actually it's 257,040. 257,040 should be equal to 85 by that one. Let's simplify again. 85 by 120, 85 multiplied by 120, we get 10,200, 10,200 minus 85 by that one minus 85x squared. Okay, so this is our quadratic equation. Let's bring it down to simplify it. So we have got the 85x squared. I will bring everything to the right. Now this one is an x here, minus 10,200 plus 257,040 is equal to 0. So this is an equation. We have to simplify it further, or we can just dive straight into the quadratic formula, but let's try to divide by 85. I'm not sure what is the common factor here. We can choose 5, or let's choose 85 itself and see that could be a coefficient of 1. So 10,200 divided by 85. We're just testing for whether we have got a common factor here, 85. So that is, I will divide that one. My number is here. I will divide by 85. Okay, I get to 120. So here I've got 120. That's fine. I'll take this one and also divide it by 85 and see. And that is 257,040 divided by 85. Okay, yeah, so we've got a good, so if I divide by 85 here, by 85 here, okay, this is an x by the way, and I divide by 85, 85 is a common factor, we'll get x squared minus, we divided earlier, we got 120x, and this one plus the one that we have just divided now, which is 3024 is equal to 0. Is that 3024? Yes. So now we have this one. I guess the best option is to use the quadratic formula because these are quite huge numbers. So let's go into the formula. Therefore, for our x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, just to solve that in. And then we know our b is negative 120, so that will be plus 120, negative negative, plus or minus the square root of 120 squared minus 4. A is a 1, C is a 3024. Everything is divided by 2a, okay, which is 2 times, which is 2 by 1. Our a is 1. Okay, and let's put it into our calculator. And now clear there. So I have 120 plus root of 120 squared, okay, minus 4 into a is 1, so it's 4 by 3024, and go on to divide by 2. What is our first answer? I'm getting 84 there. That's a good number because it has to be the number of sandwiches. We will not take a decimal value. So our x will be equal to 84, or now we used the plus first time, so we have to use a negative now to see if there's another answer there. So I'll scroll back, delete the positive, insert the negative, and I'm getting 36 or 36. So it means there are two possible values for the number of oranges. Oh, I'm talking about oranges now. For the number of sandwiches here. So we have got x over 120, and so which means this x can be an 84 or it can be a 36. Now from this condition that we are given that there are more people, more passengers who choose meat. So that gives us a clue that we must have 84 people who must choose meat sandwiches, because 84 is greater than 36. So it means if there are 84 people who choose the meat sandwich, therefore the number of people who choose the number of sandwiches that we have here is 120 minus 84, which is going to be 36. So the value here is going to be 36 over 120. So now to answer the question after working all that one out, we can say therefore the probability that the first person chooses cheese, cheese sandwich is going to be how many cheese sandwiches are there. So that will be 36. Okay, that is 36. That is 120 minus 84. So that is there are 36 out of 120, which we can simplify to 36 divided by 120. We get number 3 over 10. 3 over 10, or you can write it as 0.3. Okay, so that solves this question on probability. This is the DBE 2022. Okay, subscribe, and if there are any comments, please put your comments in the section, or something that if there's something that you need more clarification on, please just add it on the comment section, and I'll be able to come back to you and give feedback. Otherwise, I'll see you in the next video. Bye.